Yeah, so on chapter 8, we basically started with lines. We did talk about graphing points and quadrants. May see that plot points and name quadrants. Just basic stuff on your coordinate system. So yeah, we did start section 1, but that was the extent really of what we did in 1. In section 2, that's where, yeah, we started talking about lines. And yeah, so we graph lines several different ways. Just from the equation, use a table to graph lines. One way to do it, right? So I just give you a table, you fill in the table, sort of thing, and then graph the line. We also did with the intercepts. So that is definitely a distinct possibility to have that, be able to do that too. So just to review on the intercepts, how do we do those? How do we find those? The x-intercept is found by setting y to be 0. So if you want to find the x-intercept, you set y to be 0, and then solve for x, and then the y-intercept vice versa, right? Set x equals 0, and solve for y. Also, we did quite a few ways. We also graph these lines. Say I'm given the slope and a point. You can graph the line, can't you? Because you just go to that point, and then your slope, and the way we did it then was interpret the slope as rise over run. So you go to that point, and then say the slope was 3/2. You would rise 3 and run 2 from that. So probably graph a line that way too. And we'll talk about some others, but that was from the section 2 we did. We also talking about slope there. We also talked about identifying whether a line has positive slope and negative slope. So be able to do that. Positive slopes go uphill left to right, negative slopes are downhill left to right. And easy enough there to figure out. And then of course, slope formula. So there's a couple of formulas probably should know. Slope formula is one of them, and it's one form of it, y2 minus y1 over x2 minus x1. Yeah, you just subtract the y's and then divide that by the x's subtracted. So know that one, of course. Definitely know that one. Seems like there's one other thing I was going to mention. Oh yeah, on the other. Also on section 2, they talked about the average rate of change. Average rate of change, and that really all you need to know there is the average rate of change and the slope are synonymous. Those two are the same. So the average rate of change is basically the interpretation of the slope So if it asks for interpretation of the slope, yeah, you're going to give it as the average rate of change. Or if it asks to calculate the average rate of change, you're just going to calculate the slope, okay? And then interpret it. Usually on the tables that, like we did, looking at one of them, the Y values was like $, and then the X values were months. So the average rate of change would be dollars per month, for example. Right? It's whatever the Y's are, the units of Y. So the average rate of change is the units of Y, as far as units go, it's the units of Y over the units of X. So without going through an example there, just to give you that. So like I said, on the example I was looking at, the units of Y was dollars, and then the units of X were months, years, whatever, okay? So be looking at that as review. All right. Now, we also talked about, going back to lines here a little bit, we also talked about the slope-intercept form of a line. And that just so happens to be, I guess you call it another formula, y equals mx plus b. So if I ask for slope-intercept form, I'm asking for y equals mx plus b. And of course it's so called because m is your slope and b is an intercept, specifically y-intercept, right? And you can use that information to also graph a line. Could add that to our list over here, but also in that section, we also talked about finding equations of lines. So be sure to go back over that if you've forgotten that. But yeah, so if I'm given information, like if I'm given 2 points, find a line. If I'm given the slope and a point, find the line. Those are two of the basic problems there. But yeah, of course, if you're given the slope, you've got your m, you just have to find your b. If you're given 2 points, well, that's where you have to use the slope formula, right? That'll give you your slope, and then you can find your b. So won't go through those again, but be able to do that. Then we also talked about functions. Function and function notation, compute. Compute a value given a function f of x equals this. Be able to compute f of whatever. Use a function notation. Of course, we also mentioned that the linear function is just like slope-intercept form, except you've got f of x equals mx plus b. So that's putting it in linear form. Function form. But it's just the same as slope-intercept, just in function form. Let's see, what else do we do there? Yeah, and that's where we also talked about the cost and the revenue. Get a cost function and a revenue function. So there might be a question. that cost minus revenue, but cost and revenue problem. And then the other one was, what do we want to call it? Using a table to get, or information from a table to get the linear model or linear function. And so they were usually going to specify which two values to use, but anyway, go back and review that, because that'll be probably a good one. And then last but not least was our quadratic functions. Be able to graph those. Quadratic functions. Yeah, so we graphed pretty simple ones, but be able to graph quadratic functions. And part of that is determining easily, we can easily determine whether it opens up or down. Of course, the other thing there is talking about the vertex. You know, sometimes you can graph it and just see what the vertex is, but one other formula set to remember, vertex formula. Remember your vertex, usually you denote that as h comma k, and then the vertex formula, h equals negative b over 2a, whatever that equals, then your k value is f of then whatever h is. Plug it in, and that'll give you the vertex, which we use to find max of a quadratic function, like the height of the object. Well, the maximum occurs at the vertex, so I'm just going to use that formula again. Any other